All right, so my name is Alan Lumsden. I'm from the Houston Methodist DeBakey Heart and Vascular Center. I am joined today. Would you like to introduce yourself?
Sure, I'm Celia Riga. I'm a vascular surgeon from Imperial College in London.
Good morning, I'm Michael Stoner from the University of Rochester in Rochester, New York.
So we're here today to really talk about the VEITH meeting and some of the things that are featured here. And the features that we're particularly interested in are robotics and vascular surgery and then simulation. So we're very fortunate in that we have two really of the experts presenting at this meeting who are going to talk about it. So Celia, ladies first.
Sure.
You've been involved in catheter robotics for a long time. A little bit of hiatus at the moment.
That's right.
What do you think is going to happen?
Like yourselves. I think we were discussing earlier, the future is bright for robotics. The technology is out there and available with capabilities to improve imaging for vascular procedures, localization, reaching very difficult targets. The main barrier to adoption from what we've seen really is cost at the moment. And unless the cost of consumables reduces significantly to make it cost effective for hospitals and for clinicians, I think there will still be a lag before it can be widely adopted.
Now you're very fortunate at Imperial College at having a huge resource in engineers. What do they think about when the surgeon comes calling and said, we want to build catheter robots, and how do you involve them in what you're doing?
Sure. We have a very healthy, collaborative relationship with the engineering department at Imperial College, and it always fascinates me because we say, can you make this? And the engineers will say, yes, of course we can. But taking the idea from the concept and applying it and translating it to practice, as you know, is a very long process. I think the key is to have an established preclinical research program to really evaluate those technologies before they reach the market.
All right, let's get Michael involved in this conversation. Yesterday, you showed in the simulation session something that I think everybody blinked at. I don't know that I've ever been in a situation where I've been looking to see whether is that a patient, is that a cadaver? And it was neither of those. So tell us a little bit about what you're doing in this new concept of simulation.
Right, and Alan, so what we've worked on is a very high fidelity simulation model. This model uses patient-specific data, elements such as 3D printed cervical spine, mandible, chest rib cage to create a carotid simulator. This is a high fidelity carotid simulator that we're able to use with trainees, established surgeons to look at evolving technologies like TCAR, and able to even create things like immersive operating room environments for things like OR team training, crisis training, and things like that. But really the 3D printing aspect of it is the democratization of this. This is what brings it to the masses. 3D printers have gotten cheaper, easier to create, easier to maintain, and the software has gotten better and better, where then investigators or surgeons can now really create these models and create these environments on their own.
So I've obviously been very interested in imaging, and it's that CT scan potentially drives the robotics, and now you're telling me it's the same scan that can be used to drive a 3D printer to produce amazing anatomical models.
Right, exactly, and it's working with that volume. You know, essentially, if you look at the evolution of it, it's that workstations, the software, the processing has gotten cheaper and cheaper as Moore's law continues to expand. It's really something that's almost an off-the-shelf experience now, manipulating DICOM data sets and creating phantom molds to creating anatomic structures.
So when I visited Imperial College several years ago now, you did have a completely immersive kind of hybrid room environment.
We did,
Is that still going?
It's still going, and we have integrated it into the weekly timetable for trainees, but also the whole team. So we will invite the scrub nurses, the anaesthetists, the ward team to actually be fully involved in the procedure. And it's a fascinating experience, both as a trainer but also for the teams themselves, in terms of observing, evaluating and improving technical but also non-technical skills in the theatre environment.
So this meeting's always been about current practice but looking into the future. So give us your best guess. 3-4 years from now, what are we going to be doing in simulation? Because you're very different. Typically, most people talk about simulation. We're talking about endovascular simulation. You're talking about open aortic surgery, something I'm very interested in. Where are we going to be 3 years from now?
Well, I think, Alan, the volume, and we were talking about this later today, about the volume of aortic surgery in this country and how it's continued to decline. There are really not integrated surgical trainees that graduate in the United States who are competent at this juncture at complex open aortic surgery. It's going to be only through high fidelity simulation that they learn the ergonomics of the operating room, the setup of the retractors, how to handle the working, sewing the aorta deep in the surgical hole with long instruments. And I believe it's going to take these high fidelity models, which again are modular, which are economical and reproducible, to train how to run these cases.
Okay, we get the lady the first word and the last word.
Future of robotics.
Be around 3-4 years from now?
Well, I think it's still on a steep curve. However, the vision really is that in 10 years' time, we will be hands and radiation free in terms of endovascular procedures, and perhaps looking at a different way to aortic repair that would involve more intelligent tools, better imaging, new materials, moving away from Dacron and PTFE and nitinol.
Dr. Stoner, Dr. Riga, thank you very much
Thank
indeed.
you.
We appreciate you spending time with us today.
Thank you.